Welcome everyone. Today we're going to learn about basic descriptive statistics using Python. We'll work with a small dataset of 5 students' math scores. By the end of this session, you'll know how to calculate averages, medians, modes, and measures of spread like variance and standard deviation. Ready? Let's get started. First, we import pandas, which is our go-to library for table-style data in Python. Then we create a data frame called df with our 5 students and their test scores. When we run df, we see the table printed out. This simple dataset will help us focus on the math, not on cleaning data. Let's talk about the mean, also called the average. We calculate it by adding all the scores together and then dividing by the number of students. In pandas, we can simply call .mean on the score column. Here, we get 82.80. That means, on average, our students scored about 82.8 points. Next is the median, which is the middle value when you sort all the scores. With 5 scores, the median is the third score once they're in order. Pandas gives us .median, and we see our median is 85. So half of the students scored below 85, and half scored above. The mode is the score that appears most often. In our data, 2 students scored 85. Calling .mode returns a list. Here, 85. If there were 2 different scores both appearing twice, we'd see them both in that list. Now, let's look at how spread out the scores are. The variance measures the average squared distance from a mean. The standard deviation is the square root of the variance, giving us a measure in the same units as our original data. We set DOF equals 1 to calculate the sample variance and standard deviation. Here, our variance is about 48.7, and our standard deviation is about 6.98. This tells us most scores are within about 7 points of the average. In this first step, we use .max on the score column to find the highest value. When we print score max, we see 92, which is our top score. Next, we call .min to get the lowest score. Printing score min gives us 74, the bottom score in our dataset. Finally, we subtract the minimum from the maximum to get the range. Here, 92 minus 74 equals 18. The range tells us the full span of our data, from the lowest to the highest score. First, we find a 75th percentile, also called Q3, using .quantile 0.75. This value marks the score below, which 75% of the students fall. Then we find the 25th percentile, or Q1, with .quantile 0.25. When we print these, Q3 is 85.0 and Q1 is 78.0. That means 25% of scores are below 78. And 75% are below 85. Next, we subtract Q1 from Q3 to get the interquartile range, or IQR. This measures the spread of the middle 50% of our data. Here, 85.0 minus 78.0 equals 7.0, so the central half of our score spans 7 points. The IQR is a robust measure because it ignores extreme values and focuses on the core of the distribution. Rather than calculating each statistic one by one, Pandas offers a shortcut, .describe. This single command gives us count, mean, standard deviation, min, 25th percentile, 50th percentile, 75th percentile, and max all at once. It's a fantastic way to get a quick overview. Thank you for following along. I hope this gives you a solid foundation in descriptive statistics with Python. Feel free to ask any questions or explore further on your own.